What we're talking about today is completing the square, and what our goal is to create a trinomial that is a perfect square whenever I factor it. So what I want to do is go through the process. The first step would be to take the middle number, which is 40, and divide it by 2, and that'll obviously give you 20. Now the second step of the process is to square that number that we just got, and 20 times 20 is 400. Now, what I've created here is a trinomial, and what I want to do is I want to factor it. So two numbers that multiply to the 400, that'll add to the 40, would be 20 and 20. 20 plus 20 is 40, and 20 times 20 is 400. So this is going to factor, because I could use the shortcut, into a plus 20 times a plus 20, or we could write that as a plus 20 squared. And this is the preferred version of the answer. Now that's well and good. Let's do another example. That one was kind of easy. So let's go ahead and do one with a negative. We take the negative 16, we divide it by 2. That'll get me a negative 8. The second step is to square that. That'll give me a positive 64. I'm going to add that in at the end. Now whenever I take it and do the factoring, two numbers that multiply to a positive 64 that add to 16 are, well, 8 and 8. But it's not a 16, it's a negative 16, so those both have to be negative. So this is going to factor into x minus 8. Squared. Well, that's good, but what if the number in the middle is not something that's obvious? Let's say like 13, for instance. What the heck are we going to do with that? Alright, well, let's just do the process. 13 divided by 2. That's going to be, well, 13 halves. We're going to square that, and that is 169 over 4, and I'm going to add that to the end. But you say, well, what the crap am I going to do with 169 fourths? How am I going to factor it? Well, I don't know. Well, let's just give it a shot anyway. Two numbers that multiply to 169 over 4 that add to 13. Well, how did I get 169 over 4 in the first place? Well, I said 13 halves times itself. So let's try that. 13 halves times 13 halves. But what does that add up to? Well, 13 halves plus 13 halves is equal to 13. Is that what I needed? Well, yeah, it is. It just so happens that this number on the inside of the parenthesis here is always going to be these numbers right here. Now we can do the shortcut factoring, and that's going to be x plus 13 halves squared. And this is the fully factored version. Now, what do we use completing the square for? That's the question. Well, there's lots of things that we use completing the square for. One thing that we use completing the square for is solving quadratic equations. It's not a difficult equation to solve. You could use the quadratic formula if you wanted to, but we're going to go through the completing the square process. The first thing is kind of the opposite of what we normally do with quadratic equations, is that's to get rid of the number that happens to be at the end. Because remember, I needed that blank to fill in the first place. Plus something is equal to, now it's not 0 anymore, it's 72. Now this is an equation, which means if I do something to the left side, I also have to do it to the right side. We're going to go ahead and complete the square on the left. What I want to do is divide the 14. Negative 14 divided by 2 is negative 7, and I'm going to square it. When I square that, I get 49. Now, since I just added 49 to the left side of the equation, this is what everybody forgets. We also have to add the 49 to the right side of the equation, so I want to say plus 49 over here as well. This will give me a new equation. It's going to be x squared minus 14x plus 49 is equal to 72 plus 49 is 121. What I need to do now is just do the factoring process. Two numbers multiply to 49 that add to negative 14 are 7 and 7, both negative. X minus 7 squared is equal to 121. Now you say, why did I do that in the first place? Well, because this is an easy equation to solve. I have a squared equation. What I need to do is undo the squaring by square rooting both sides. And that'll give me a new equation. X minus 7 is equal to plus or minus 121, square root of 121, which is 11. And then I can just solve this by simply adding 7 to both sides of the equation. I have x is equal to 7 plus or minus 11. Now that is two answers. X is equal to 7 plus 11, which is 18, and x is equal to 7 minus 11. And 7 minus 11 is a negative 4. Let's do another one preferably that doesn't have a nice answer at the end of it, like 4 and 18. Those are pretty numbers. So let's find one that's a good one that has a I or something involved in it. We can't factor this. We could quadratic formula this. I'm going to complete the square. I'm minus the 46 from both sides. a squared minus 2a plus something is equal to a negative 46. What I want to use is completing the square process. I take the negative 2 divided by 2, and I get negative 1 squared, and I get positive 1. Now, two numbers, well, of course, if I add 1 to the left side, I also have to add 1 to the right side. So we want to make sure that we're doing that. I'm going to go ahead and factor this. Two numbers multiply by 1 that add to negative 2 are that negative 1 and negative 1. A minus 1 squared is equal to negative 46 plus 1 is negative 45. Now from here I need to solve the equation, get a by itself by square rooting both sides. A minus 1 would then be equal to the square root of negative 45. Now the square root of negative 45 will have to be broken down. Do not forget that it is a positive and negative square root of negative 45. Add 1 to both sides to get rid of it, and we have a is equal to 1 plus and minus the square root of negative 45, which we will then have to break down. That is 9 and 5. 9 is a perfect square, so we'd say a is equal to 1 plus or minus 3 root 5. And that would be my final answer. Again, the biggest mistake that people make on these type of problems is right here. When you add 1 to the left side, you also have to add 1 to the right side. People forget this part all the time. They'll add the 1 on the left side, but won't do it on the right side, and they'll end up with the wrong answer because of that. Oh, don't forget about the I.